Solar activity is dropping off a cliff. We're at 0 sunspots. The radio flux is only at 77 solar flux units. Here at the Smash News Network, we wonder if that means it's time for you to panic. Move to a bunker or campsite in Colorado and listen to a bunch of hot air. And the answer is no. Anyway, here's the sun. This is 304 angstroms from the SDO. The Solar Dynamics Observatory. We're having a shortage of sunspots and coronal holes at the moment. And we can see sunspot 2904 here degrading to plage. Again, 0 sunspots. That's how many we've got at the moment. 0. So there is another plage up here. And there is a bit of activity over here, but not a sunspot. We'll see if that's changed by the end of the video. Here's 335 angstroms. And no real need to do any zoom-ins today. We've got all full disk imagery. Again, the radio flux at 77 solar flux units. And there's the 1-year chart of that. The black line there is the 10.7 centimeter radio flux. The red line below it is the sunspot number. And here's the Space Weather Enthusiast dashboard. No apparent expectations of things like geomagnetic storms or unrest. Just low solar activity in general. And let's take a look at Earth activity here in the form of earthquakes. We've seen an interesting swarm off the coast of Oregon, including a high level 5 magnitude quake. Could it be a foreshock? We would just recommend that all of our viewers who are in earthquake-prone zones to have an earthquake plan if building facades start to collapse, for example. Know which ones might. If you're in places like these, there's sort of a significant possibility of major quakes. I would say especially in those areas. And I don't try to forecast earthquakes because, well, it's just statistical analysis. And, yeah. Anyway, there was also a 4.3 in Kansas there. So kind of a rare spot for a quake there. So yeah, the quakes continue off of the coast of Oregon here, and we're hoping that that large 5 magnitude quake that we covered in yesterday's daily space weather video was not a foreshock. Largest quake of the past 24 was a 6 magnitude there near Japan. I think on Japan, actually. We'll cover it in a minute. Indonesia saw a 5.1. You can see a series of quakes still happening off the coast of Oregon there. So it's an ongoing event. There's a 5.3. So, yeah. These could be foreshocks, folks. Any earthquake could be you could have an 8 magnitude earthquake being a foreshock to a larger 8 magnitude quake, for example. So here's the largest of the past 24. It's this 6.0 at Japan. There's a location of that one. South of the archipelago. That one came in at 2:05 Universal Time this morning on 12/9, December 9th. Again, if you're in an earthquake-prone zone, folks, have an earthquake plan. Know which building facades might collapse. Have a bug-out bag. Be an asset, not a liability in the event of a disaster. We implore you. And let's look at volcanoes next, while we're doing brief geophysics stuff. La Palma has calmed down a little bit. It's still producing an 8,000-foot ash plume as it explodes and creates new real estate. Fuego, located in Guatemala, also exploding, flight level 150. It's a 15,000-foot plume of volcanic ash. Volcanic ash not detected at Nevado del Ruiz. Don't assume it isn't erupting. Revenador exploding, that's in Ecuador. 15,000-foot volcanic ash plume from Revenador. Sabancaya, intermittent emissions of volcanic ash are a reminder to not pole vault the caldera. Don't pole vault the caldera, no matter how athletic you are. It's just not worth it. Nevado State Chilean, located in central Chile, no emissions detected. Don't square dance the caldera. And thanks to all of our viewers who leave comments. If there's some activity you'd prefer our viewers not do around the caldera, let us know in the comments section. And perhaps we'll talk about it at a later time. Next, the GOES magnetometer here over the past 3 days. Nothing too exciting going on there. I think Earth is still in a South Pole current sheet. And indeed it is. Here's the top view ecliptic plane field plot. For you new viewers out there, this is stereo A at Lagrange point 5. This is stereo B at Lagrange point 4. Lagrangian points are gravitational equilibrium points where we can put a spacecraft, and without much use of fuel, it will remain there following Earth through orbit. Next, the line of sight view. There you go. No major changes happening there. And here's the coronal hole plot, and we are seeing a coronal hole shortage. It's official. And look, over here on the eastern side, you've got this South Pole-oriented coronal hole at the beginning of the video. Right there, it becomes transequatorial, and then it shrinks back down. So perhaps a lot of intercalate pressure building up in there. And I won't go further into that in the daily space weather video. We'll have to save that for a cosmology segment or something like that. Here's a 193 angstroms view. And you can see some of this South Pole-oriented coronal hole here. Again, coronal hole and sunspot shortage going on, folks. Is it reason to panic? Does it mean civilization's going to end? Well, not really. By the way, if you want to read more about coronal holes, you can go to solon.info. And solon.info/solar. Here, I'll put in the URL for you there. If you scroll down on the home page, you can actually find a link to historic coronal holes dating all the way back to 2002 in October. So if you want to look up historic coronal holes, you can do that. It's listed in all kinds of different features, such as the maximum solar wind derived from it as measured at Lagrangian point 1 and so on. Coronal holes, they're very important to the progression of solar cycles, as they show us the location of the solar polar field reversal process, which is taking its good old time here during cycle 25, which began in November of 2019, by the way. Coronal holes, they're super important, and perhaps even becoming more so. More about that in a later video, perhaps in a cosmology segment. So 0 sunspots at the moment. Sunspot 2904 has decayed to plage. Likelihood of solar flares quite low. And welcome everybody to the Neo Renaissance. Congratulations on realizing the channel exists. Algorithms certainly did not help us to be found by you, the viewer. So anyway, thanks for tuning in. Check out our website, smAsho.com. Changes coming to that soon. Right, Smash staff? Also, click the smAsho merch link to see our merch shop. Help support the channel that way if you don't want to become a member of smashomash.com/smashteam, which is a website that we've replaced Patreon with because our own website is just vastly superior. Our products are listed here in order of best-selling. Perhaps join the Galactic Special Forces. But in any case, certainly do not pole vault the caldera. Once again, thanks for tuning in, viewers. We got to do what we can in order to keep this channel in existence. So smashomash.com/smashteam is what we replaced Patreon with. You can find links to that on the homepage as well. Here are the latest posts on there. And there will be free publicly visible posts that do not require a paid subscription through the year 2021. X-ray profile has fallen off of a cliff. As you can see, no major flares, and the likelihood of flares is very low as well. No spikes in the proton flux. And the likelihood of that is even lower than flares. Next, the real-time solar wind, which features massive portions of missing data here. It is showing the current conditions, so we're going to cover it. Current solar wind conditions, 359 kilometers per second as far as the solar wind speed. Solar wind density around 5 protons per cubic centimeter. Everything else relatively unremarkable besides a dearth of data. Not Darth Vader data, a dearth of data. A lack of data. It's the opposite of a plethora. So here's the KP index over the past 3 days. That's a measurement of global geomagnetism. And the last 6 hours have featured a KP0. And you can see very low magnetohydrodynamic pressure here in the last 4 hours, as modeled by the Space Weather Modeling Framework. It shows you Earth's magnetic moment from space, out to about 12 Earth diameters. Some changes happening here in the middle of the movie to the plasmasphere, but primarily just homogeneous magnetohydrodynamic pressure, modeled in nanopascals here over the past 4 hours. Nothing too exciting going on there. How about ground magnetic perturbations? We expect to see more of the same. Not a lot to cover, but we got to cover it daily because it's a daily space weather video. So this, like the last one, this is 4 hours of ground magnetic perturbations. This is modeled in nanotesla, which is magnetic flux density, not magnetohydrodynamic pressure. And we're just going to let that play through. We don't edit the videos. In fact, this one was actually streamed live originally. Our format was created this way on purpose because we like the live format better than recorded videos. It's just superior, in my opinion, because of the tension that it creates and the thought that it causes to happen on the spot. Anyway, like the last frame there, that's 4 hours of magnetic perturbations on the ground level. And before we do a solar system forecast, let me just check the life of the stream, and it looks like it's doing just fine. Thanks for leaving a comment. Once again, Red Split Rail Fence. Here at the Smash News Network, least busted name of news, we read all of our comments, and we greatly appreciate everybody who's getting involved. Part of the reason these videos are good is because of the interactivity. Anyway, here's a solar system forecast. Here's where things will be in a week, approaching another full moon there. Looks like on December 17th or 18th, we'll have another full moon. Here's a star chart. It shows you the ecliptic as a yellow line and the galactic plane as a blue line. We've got a cosmology segment coming up. And here in the Lehigh Valley, the Sun, Mars, and I believe Mercury now behind the Sun. Indeed, Mercury, Mars, and the Sun all appearing there on the ecliptic here over Lehigh Valley, Pennsylvania. Let's look at a coronal mass ejection watch here. The view from Lagrange point 1 and Lagrange point 5. So stereo A is going to be on the left, and the LASCO C2 is going to be on the right. There you go. Lagrange point 5 over here, Lagrange point 1 over here. There is still a coronal mass ejection watch in place. I'll just leave it there. And let us know in the comments if anybody else is forecasting coronal mass ejections. I'm not sure anybody knows how. It all has to do with the physics. And let's do a cosmology segment. Today's cosmology segment's integrated into the daily space weather video. It's incentive to watch these videos, especially if you want to know what's going on in space. So today's quote random and quote number is 606, which is a very interesting low mass X-ray binary. Why is it so interesting? It's because of this. It went into a hyperactive X-ray state here. And it's also quite cyclic. As you can see, it's got this fairly consistent pattern of X-ray flux there. It's the low-mass X-ray binary XTEJ1701-462. I know it's a catchy name. Don't try to memorize it. You can look it up. It's number 606 on the transients page at the Neil Gehrels Swift Observatory. Neil Gehrels was very interested in exploding things, the universe's largest explosions, and that's why the observatory is named after him. It takes a lot of energy to produce those X-rays. Here it is over the past 30 days. And let's take a look at this visually. So here it is in X-ray, and if you look at the photometric points here on the CDS site, you'll find that it does not really show up brightly in a lot of frequency spectra. A lot of the electromagnetic spectra appear dark on this object. But it's a great false color X-ray image there. Let's full screen it. So it's a pretty bright X-ray source there, this low mass X-ray binary. Looking at it in some other frequencies here, we see a heap and help and a nothing on the Galix. Does it show up in infrared? I'm not sure if I see a signal. I indeed do see a dim, cold signal there. So it's kind of cold. It's kind of bright in X-ray. It does have a certain cyclicity to it. And again, the most interesting feature here was that it went into a hyperactive X-ray state there back in 2005 and 2006, and then it just kind of returned to its normal state of affairs. That's today's quote random and quote object, low mass X-ray binary XTEJ1701-462. And let's show it in X-ray again here before we continue on. Now, you may follow me on Instagram and you may not. We'll get to that in a minute. First, the astronomy picture of the day, a great image of the solar corona. So there's a total solar eclipse, and that's from December 4th of this year. Only visible around Antarctica. And you get a great view there of the solar corona. You can see some of the magnetic field force lines there, where there is gas-oriented. Plasma orients to magnetic fields. And let's talk about Instagram. Do you follow me on Instagram? Instagram.com/smashamash. Thanks to everybody who has. And we've put up some recent new posts. Shout out to Bubbles. Anyway, somebody else you may find on Instagram is somebody that I follow for a while. She actually rode for our cycling team, I think, for a summer or for at least some races. It's Amanda Birch, track cyclist and PhD. Why do you care? Well, it's because, and shout out to Amanda, she's going to space, I think. This is 1/3 of the next series of candidates to go into space. So Amanda's got a PhD in biomedical engineering, and she wants to do some experiments in space in microgravity because of the way the microgravity environment affects the formation of things like cells. They're able to they're able to sort of propagate in a more three-dimensional fashion in microgravity. So we'll be actually reaching out to Christina, not Amanda Birch, Christina Birch. My bad. We just know her as Hup Like Whoa. Anyway, she's on Instagram, Hup Like Whoa. She's married to the fastest mustache in cycling. Perhaps more on that later. Good luck to you, Christina Birch. We hope that your speed increases to escape velocity so that you too can enter microgravity. Quote, on Earth, under gravity, cells are limited by their own weight, and their sizes are limited, so they can usually only grow in 2 dimensions, where in space, without Earth's gravity, they expand more readily. So one of the 9 likely applicants. Once again, good luck to Christina. That's today's Cosmology segment. Check our playlists for lots more. Over 200 Cosmology segment videos, as we cover a lot of stuff here besides daily space weather on the Smash News Network, least busted name in news. Let's get back to space weather. Charging hazards. They're non-existent at the moment, and this is involved with the electron flux. So let's take a look at that. There's a 1-year chart. We're just at moderate levels here. Nothing to write home about. Close to warning levels. In fact, I think the GOES 16 might have gotten into warning levels for a brief moment there. No big deal. Pretty smooth there. Here's the forecast model. And perhaps there is a coronal hole wind stream expected here. I'm not sure what the expectation is for a dip like that. Not exactly sure. No arguments there in the NOAA forecast. The green boxes are the forecast. The yellow diamonds are not lucky charms. Those are the observations. Next, a diagram of Earth's Van Allen belts, because we're going to show you the total electron content forecast next. The most likely places of GPS errors occurring would be the redder this visualization gets. If you're under a spot that's even yellow, you're unlikely to have accurate GPS readings, so turn on your location accuracy settings to use Wi-Fi to help calculate your location. Also, we're going to show you the F ionosphere layer, located at about 300 kilometers of altitude. Feel free to pause the video if you want to look at electromagnetic radiation penetration into the atmosphere, or perhaps temperatures of the thermosphere at solar minimum versus maximum, or perhaps to look at molecular concentrations up in those upper reaches of Earth's very diffuse outer atmospheres. Here is the F layer in vibrational frequency. We do see some anomalies happening here for sure. Certainly some high-frequency ones in the southern hemisphere. And we're going to show you the anomalygram as well, because this is not super well understood, I don't think. There's a lot of vibration going on above your head. The F ionosphere layer is in many ways the bridge between Earth and space. So it gives us insight into things like Earth's magnetic field, the same way the total electron content forecast does. You can see quite a bit of low frequencies here around the equator and in the northern hemisphere. Some sudden low frequency anomalies here in the South Pacific. Anyway, here's the latest image. That's 1300 universal time for the ionogram. Here's 1300 universal time for the anomalygram, and that's anomaly in megahertz from the 30-day median. By the way, do you watch our meteorology segments? We typically premiere those on YouTube before the daily space weather videos. This video was originally streamed live to Twitch, by the way. It's just such a great live streaming platform that we just love to use it. Thanks to our followers over there. Please support the channel via the links and via hosting our channel. That would just be great. If you're a big channel, please host our channel. Thanks to our BitChute subscribers. Don't forget to press like and subscribe if you're viewing the content on YouTube. Congratulations on realizing it exists. And let's get back to our bonus features. Yes, we've got bonus features for you folks. So the first thing we're going to do here is the ground-based solar observatory, right? So here's El Teide, Spain, the most recent solar imagery we can get here from the National Sunspot Observatory. The sun, it's not going to kill you. It's responsible for all life on Earth. And I realized in the mid-1990s that I had to do a deep dive into solar activity. I think I've done it. Anyway, coronal mass ejection watch remains in effect. Here's the GOES 16 SUVI imagery. Just spectacular imagery there with the wide field of the GOES 16. And if we do see a coronal mass ejection kicking off in the earthly zone today, we'll probably make a video about that. Here's the latest intensitygram to show you 0 sunspots. Here's the latest magnetogram. There's a place to keep an eye on over there. And when I say eye on, pardon the pun, there is no sunspot there. And we'll close that with a composite and a 171 angstroms view. So this is ionized helium and iron together. Just great imagery there from the Solar Dynamics Observatory. And there's 171 angstroms. Thanks for tuning in, folks. Please visit the links below the video. Support the channel. Get all kinds of additional information at smashomash.com/smashteam. And may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted. Name it news.